Hello students, this video is about Lami's theorem and we are studying this theorem because it will be helpful to us while solving questions based on concurrent forces. We can also solve them by other method without using this theorem, but by applying this it will be easier to solve those questions. So that's why we are studying this. So this theorem is for concurrent forces basically, and to understand this we have to consider three concurrent forces acting on some particle under the equilibrium. So I am going to draw a diagram for that. Suppose this is the point where these three forces are acting. So I am considering three forces. First F1 vector, second F2 vector, this is F2 vector, this is F1 vector, and the third one is in this direction, F3 vector. So these are the three concurrent forces such that the angle between them are alpha between F2 and F3, beta between F1 and F3, and gamma between F1 and F2. So this is the diagram that is representing three concurrent forces acting on this point and making angles alpha, beta and gamma respectively, and these forces are in equilibrium. So we are writing here what we have considered. We consider that three concurrent forces F1 vector, F2 vector and F3 vector acting on a particle under equilibrium such that alpha be the angle between F2 and F3, comma, beta be the angle between F1 and F3. You can also see in the diagram that F1 and F3 के बीच का angle is beta, and last one is gamma be the angle between F1 and F2. Now we are going to represent these forces F1, F2 and F3 vector by the sides of a triangle, let it be ABC, taken in the same order. So we are going to represent these forces as the sides of a triangle without changing their respective angles with each other. Means जो angle है जिस pair के बीच में, it will remain same, and these vectors will represent the sides of a triangle in the same order. So let's see how we can do that. So this force F1 vector will remain like this only. F1 vector is at its position only. Now F2 vector. For F2 vector, I am going to displace this vector from this position to this. We are just displacing this from this position. So it will be like this. Means हमने बस F2 को यहाँ से displace किया to represent the side of the triangle. Its magnitude is same. However, the angle between F1 vector and F2 vector. So this is the angle between the direction of F1 vector. This is the direction of F1 and F2. It is also same, that is gamma. Similarly, we are going to displace this F3 vector to here, and it will be represented as this. So magnitude of F3 vector is also same. We are not changing its magnitude, as well as the direction between F2 and F3 and F1 and F3 will remain same. So the angle between F2 and F3, it will be here F2 and F3 के बीच का angle is alpha. So this is the direction of F2 and this is the direction of F3, right? And this angle is alpha. Now for F3 and F1, this is the direction of F3 and this is F1 and the angle between them is beta. So if we compare the two, we just represent these vectors in the form of a triangle or the sides of a triangle. We haven't changed their magnitudes as well as their angles. Okay, let this triangle be ABC. So we are naming it as ABC. Now if this angle is gamma, then the angle CBA means this angle, interior angle of the triangle, it will be 180 minus gamma, or we can write it as pi minus gamma. Pi is equal to 180. Similarly here, angle CAB, the interior angle CAB, it will be pi minus beta, and this one is pi minus alpha. So we have all the three interior angles of the triangle ABC. Now we are going to apply the law of sines in triangle ABC. So we are going to apply law of sines. This is a trigonometric relation in triangle ABC. And according to it, in a triangle ABC, the ratio of the forces or the sides F1, F2 and F3 to that of the sine of angle between the other two sides is equal. Means for F1 we have F1 upon sine of pi minus alpha, that means F1 and the angle between other two sides. So F1 के upon में हमें put करना है sine of the angle which is in between the other two sides, that means F2 and F3. Similarly, in case of F2, we have to put in denominator sine of angle pi minus beta, means the angle between F1 and F3. So it will be sine of pi minus beta, and for F3 it is upon sine pi minus gamma, because angle between F1 and F2 is pi minus gamma. Now we know that sine pi minus theta is sine theta itself. So we can write it as F1 upon sine alpha is equal to F2 upon sine beta is equal to F3 upon sine gamma. Now to state Lami's theorem, we are going to compare this result with this diagram and we can give the statement. So it states that if three forces acting on a particle kept in equilibrium, then each force, all the three forces, then each force is proportional to the sine of angle between the other two forces. Now, how come the proportionality? So since these three factors are equal, let it be equal to some constant k. I am considering that these values are equal to some constant k, then these values are separately equal to this k. That means F1 upon sine alpha is equal to k, F2 upon sine beta is equal to k, and F3 upon sine gamma is also is equal to k, which is a constant. That means F1 is equal to k sine alpha, F2 is equal to k sine beta, and F3 is equal to k sine gamma. Since k is a constant, so I can write F1 is proportional to sine alpha, F2 is proportional to sine beta, F3 is proportional to sine gamma. So this is what Lami's theorem states, that if the three forces are concurrent or they are acting on a particle and are in equilibrium, then each force, each of these three forces is directly proportional to the sine of angle, that is here sine alpha, sine beta, sine gamma, between the other two forces. Means the angles are those angles which are between the other two forces. Means for F1 we are taking alpha, which is between F2 and F3. For F2 we are taking beta. So for F2 we are taking beta, and beta is in between F1 and F3. So basically this force is going to be proportional to the sine of angle between the remaining two forces. Okay, so now we are going to state Lami's theorem. It states that if three forces acting on a particle kept in equilibrium, then each force is proportional to sine of angle between the other two forces. This is how we can give the statement of Lami's theorem. It states that if the three forces are concurrent and are in equilibrium, then each force is proportional to the sine of angle, and the angle that we are considering is in between the other two forces. That is all about the Lami's theorem, and we are going to use this theorem while solving the numericals. So we will use this theorem to solve numerical, as well as we will do them using other method also, so we can compare the two process in the next video. For that, stay tuned and keep studying. Thank you.